Good morning, everybody. Today, we're answering the question, what is a router on a stick? Sounds like the kind of thing you'd get at a carnival, but unless they got a network in the back, not likely they got one. All right. Short answer, if you've got a router with a trunk going up to it, from whatever kind of single interface, or cable anyway, and the other end is going down to a switch with a bunch of trunked VLANs, you got yourself a router on a stick. If you want to know more, stick around. Let's get into it, and I think diagram time right away, so Tiny Brian? Alrighty, y'all. This should look pretty familiar if you're coming from last time around, same diagram. And last time, what we had, there we go, okay, cool. We had this idea of an access distribution in core, which isn't directly, integral to the whole router on a stick thing, but we had one anyway. We had multiple VLANs, in this case 1, 10, and 20, and hosts on different networks. I only put them on 10, 0, 10, 0, and 10, 0, 20, 0 on VLANs 10 and 20. And we trunked them up between the switches, and we had some link, we're imagining, between this distribution switch 1 heading up to that router. And again, with some kind of single cable plugged into the router and then plugged into the switch down there. And we would have something like switch port mode trunk, switch port trunk allowed VLAN 10, 20, and maybe something like switch port trunk native VLAN 1, right, on the switch side. On the router side, we would have an equivalent thing. Now, I thought we were going to do layer 3 switches this week, but I'm going to hold that off till a little bit down the way. But if it's a layer 3 switch or if it's a classic router, either way, you are now going to need to be able to send those 3 VLANs up to it and have those different 2 or 3 different routed interfaces on there. Any traffic that's now going to be routing between those 2 networks would now go up that wire and back down again, right? If this computer here, let me give these things some IPs, and a gateway. Okay, here we go. Let's say this computer is 10.0.10.100/24 and a gateway of 10.0.10.1. And let's say the computer plugged in, just next to it over there on port 3 has a different address in that different network. We'll say it's we'll say it's 10.0.20.100/24. First 3 octets are different, so different network. And its gateway is 10.0.20.1. Okay, if we're sending some ping or something from the computer over here on 10.0.10.100 to 10.0.20.100 from its MAC, to the MAC of its default gateway, yeah. Okay, well that's gonna come up the wire, hit port 2 of that switch. Switch is gonna say, oh, the MAC address, the default gateway is out port 24. Get it up to that switch up there. It says, oh, that MAC of the default gateway is out my port number. I didn't label it 1, whatever. Send it up the wire on VLAN 10. It routes it to VLAN 20, and it comes back down the same wire. It's not technically the same frame, the same Ethernet message, because it'll now have a different MAC header, and that'll be from the MAC of that router back down to the MAC of the host over here with 10.0.20.100. Yeah, and that distribution, the switch says, oh, I know where that destination MAC is. I send it out whatever this port is. Switch 1 says, oh, I know where that MAC is. I send it out port 3 and it makes it over here, right? And in that way, when these 2 computers in different networks wanted to talk to each other, they still got to go through their router, but they had to go up the wire, up the stick, and right back down again, routing between these 2 networks. Router on a stick. Certainly not the only way to do it. And when we do hit, especially those layer 3 switches, we'll see where this is a little less likely today, but still, common practice. Okay, and so I just want to show you all real quick setting that up. So there we go. Check it out. This should look pretty familiar. I changed up our diagram back over here in GNS3. I got this going here. We've now got this access switches. Here we got the switch number 11 and 12 with our clients attached to them. These are going to be in VLANs, the moment 10 over here on the left and 20 over there on the right. Some distribution switch with those VLANs trunked up to them. And then a router up here where we are also trunking those VLANs up to them. And we could certainly have clients in VLAN 10 or 20 on any of these, right? We could have, dozens, hundreds of different VLANs, and we just with the different hosts in the correct VLAN and trunk them all up to that router. Love it. And here's our basic configuration, what we got going. Up on the R1 on this Cisco, that is going to be on its port number, I think, gig 1/0. So show run interface gig 1/0. Yes. And there's nothing there. What? What? How is there nothing there? Well, because we've used something called sub interfaces. A sub interface is a thing that you would classically do on a router on a stick if it is an actual router, not a layer 3 switch up there. You might do it on a layer 3 switch, just don't have to. Here we go, check it out. Gig 1/0, oh, nothing. But gigabit 1/0.10? Yeah, if you literally say interface gigabit ethernet, or whatever the port number is, and then dot some number, that is creating a sub interface on there. And so basically it's splitting that one physical port. It's splitting that one physical port up into multiple logical ones. So once we've created that one here, gig 1/0.10, then on Cisco style, you would say encapsulation.1q. 802.1q is that IEEE standard for VLAN tagging we talked about. Encapsulation.1q 10 is saying this subinterface is going to expect all of its traffic to show up whenever it comes up that wire and hits that port. If it's got a VLAN tag of 10, then it gets associated with this subinterface. Technically, that .1q10 does not have to be the subinterface, 1/0.10, but dude, think of yourself in the middle of the night if you're trying to fix this, or if someone else is. Make it make sense. Okay, and then I say in here IP address 10.0.10.1, and then my network mask, this is the equivalent of that /24, dotted decimal 255.255.255.0. Press enter. Cool. Then I can exit out of there and say interface gigabit ethernet 1/0.20. Encapsulation.q. .1q20, and now any traffic that shows up on this port with that VLAN tag of 20, I don't got that many fingers, that shows up with a 20, is going to get associated with this subinterface. And we're saying IP address 10.0.20.1 there. Now, if I had put an IP address directly on the port, any untagged traffic that shows up is going to get associated with it. And I could just keep adding sub-interfaces on here for, a whole bunch of different VLANs. It's going to be limited to like that piece of hardware, that operating system. Maybe there's some limitation. Otherwise, you get the full about 4,000 VLANs in theory, at least. And that's this port right here, gig 1/0. And the sub-interfaces .10 is where VLAN 10 stuff's going. The sub-interfaces gig 1/0.20 is where the VLAN 20 stuff is going. And now, this computer over here, PC1, with an address of 10.0.10.100 and a gateway of 10.0.10.1, should be able to, kind of give it away, I already tested here, should be able to ping not just its gateway, but hosts on the other side as well. So ping 10.0.10.1. Yep, it's happy. Ping 10.0.20.1. Oop. Okay, I mistyped, and it kind of might look like it's working. Hey, real quick, made a mistake, but this is a good opportunity. Check this out. It kind of looked like it's working. It wasn't nothing happening, but sometimes when you ping, you got to look more closely, because check this out. ICMP type 3 code 1 destination host unreachable. And it came from 10.0.10.1. Yeah, what happened is we sent that ping message to 10.0.201. I'm a little surprised that this little virtual PC sent it at all, because it's not a valid IPv4 address, but I guess it's not smart enough to tell that. It just threw it down the wire anyway. And our router, our default gateway, came back with an ICMP error message for us, saying destination host unreachable. I don't know what to do for you, man. I can't get there. Yes. Okay. If you get that, try another IP. So, ping 10.0.20.1, the other default gateway. Now we're good. And 20.100. is one of the other ones over here. And 20.101 should be the other. Yeah. Okay, and so now this traffic is coming up the wire, sourced from the MAC address of that PCU1, destined to the MAC of its default gateway. Switch just passes it on up. Next distribution switch just passes it on up. Hits that router. Router destroys, recreates the frame header, drops it onto the other VLAN. Still from the same source and destination IP at the packet level, but at the Ethernet header, different. Now it's going to come from that router MAC to the MAC of whatever host on the other network and get delivered on down. Perfect. The response is going to do the same thing. All right, and this is a router on a stick and sub interfaces along the way. Oh, man, I'm having a blast, y'all. Thanks so much for all this. I hope that you're having a great day too. Like always, like if you like it, subscribe if you're looking for more. And hey, I love it when y'all leave me comments. I appreciate those messages y'all been dropping in there. If there's anything you want me to take a look at for you or include in our list of things, let me know. Y'all have a great day.
Look. It's not what you think. It's not what you think. You think Decepticons don't get metaphor. Ha! Shows what you know. That's an access point. Hey boss, is this what you wanted? Bet you feel pretty dumb.